My name is Zach Hansen, and the title of my thesis is Early Recognition of High-Performance Computing Center Overheating Events with Neural Networks. My thesis director was Dr. Christopher Turner, and my second reader was Dr. Yong Chen. The motivation for this project was born out of my experience working at Texas Tech's data center, the High Performance Computing Center, also known as the HPCC. What I learned there is that data centers are critical tools for scientific research. I also learned that emergency shutdowns can damage data center productivity. For instance, if the Quanta cluster at the HPCC goes down for a single hour, that represents 16,812 CPU hours of lost time. Furthermore, I learned that progress that is made on active jobs can be lost. So if an emergency shutdown occurs and they have to kill active computations, all the progress that has been made thus far is lost. This obviously incurs additional costs and carbon emissions as electricity is then required to recompute these terminated jobs. During the course of this project, we noticed a number of overheating events at Texas Tech's HPCC. In the event that the compute room grows too hot due to some sort of mechanical failure or software glitch, then an emergency shutdown is sometimes necessary in order to protect the computing equipment. From December of 2018 to November of 2019, we observed 17 abnormal thermal conditions in the HPCC, and these are what we chose to study for this project. Now, we attempted to provide early recognition of these abnormal thermal conditions or overheating events using neural networks. What we determined was that the deep neural network had higher F1 scores than the long short-term memory network. Essentially what this means, an F1 score is the harmonic mean of precision and recall, so essentially how well the network captures overheating event, how accurately it records this event. So we discovered that both networks displayed non-zero activations before the HPCC's threshold scripts activated for all events. I should clarify that the threshold scripts are a threshold value-based alarm system that the HPCC uses to detect overheating events. So both networks were able to recognize a developing an event prior to the HPCC's current methodology, provided you count a non-zero activation as recognition of the event. What we ultimately decided was that supervised learning is likely not an optimal approach to this problem. Supervised learning was the approach we took. We inspected a bunch of temperature graphs and determined what represented an abnormal event and what represented normal operation, and then used that to train and judge the neural networks. However, we decided that this is likely not the best way simply because if we're trying to discover events before they're recognizable based on visual inspection or threshold values, then it's pretty difficult to evaluate the success of those models based on visual inspection or threshold values. So the lessons I learned from this thesis is, number one, research does not always pan out the way you want or expect it to. I got too tied to a particular outcome, and I learned that I needed to curtail that bias a little bit. I also learned that I should be more comprehensive in my literature review. Learned how to conduct a literature review in the first place, which was useful. Also learned that save more time if you're slow and careful as opposed to fast and sloppy. And good notes are critical because, that would say. I also learned, I gained a bunch of valuable technical knowledge. For instance, the language R is extremely useful for statistics or deep learning. I learned how to program in parallel for collecting the data for this project. Went into this project knowing nothing about deep learning and have come out with a little more knowledge about it. And I've also got gain some familiarity with the typesetting system LaTeX, to which I am fully converted. Thank you.